Welcome back. Well, we can create scalar, vector, matrix, and tensor in TensorFlow in a various way. Let's try constant method first. First of all, we have to import TensorFlow. By the way, we will write codes in Google Colab. You can simply search for it in your browser like this. Google Colab. And go to Google Colab and sign up and sign in using your email if you are already not signed in or sign up. And then here you can click on new notebook or cancel it and go here, click on file and new notebook. After that, click on connect here to connect with the machine. After you are connected with machine, then you will simply import the TensorFlow statement. So import TensorFlow and add an alias if you prefer. Actually, adding an alias is not mandatory. And call the constant method of TensorFlow using the tf alias. We can pass any value here. Let's pass 10 here and assign it in a variable. I'm naming the variable scalar, as we have assigned a scalar value. Now let's print it. And we can see a bunch of information here. If we print using Python's print function, then we will see the object, which includes all information, like it's saying it's a tensor object which does not have any shape. Data type is in 32. Let's change the data type. It's the same process like we did in NumPy. So we can say dtype equal to int 64. And we have to use TensorFlow's int 64. tf.int64. Execute it, and we can see our data type is changed. But if we print using TensorFlow's print method, tf.print scalar, then we will see only the value, not the whole tensor object. Well, what about a vector? Let's try that. Let's create a single dimension array with some values and assign in a variable. Let's name it scalar, as it's a scalar type of data. Sorry, it's a vector type of data, so let's name it vector. And now let's call the constant method of TensorFlow and pass our vector here and assign it in a variable. Let's name the variable vector constant. After executing, let's print it. Let's print using Python's print function. And we can see it's a tensor object. Its shape is 4 and data type is int 32. So if we check our vector's dimension, we will see 1. And we can do that using the endim property. So we can say vector constant dot endim. We can see it's 1. And we can check the shape using the shape property. Vector constant dot shape. So what is this for? We can see there are 4 elements in our vector. So if we increase the number of elements, let's make it 5. Execute it. and execute it. And we can see now our shape has increased. What about dimension? It's still same because vector is one dimension array and we know this. What about shape? Let's check it. We can see it's 5. Well, we will understand about shapes more clearly if we make a matrix. So let's create a matrix. tf.constant, and here let's pass one matrix, a two-dimensional array. And let's pass some values here: 2, 4, 6 and 8. Let's assign it in a variable and let's name the variable matrix. Execute it. Okay, I misspelled the name of the method constant. And let's check the matrix. Awesome. We can see it's a tensor object. And the data type, numpy, everything is perfect. But there is one difference, the shape. We can see the shape is 1 by 4. So what is 1 and what is 4? The 1 is number of row and the 4 is number of columns. We can see there is only one row. And inside the row, we can see there are 4 columns, 3 and 4. Let's try adding one more row. Execute it and check it again. This time we can see 2 by 4. So 2 rows and each row has 4 columns. You see, one column, column number 2, column number 3 and column number 4. Hope you understand about shapes. We can see 5 here because it's just counting the columns. There are 5 columns in this array. That's why we can see the shape 5 here. And we can see 4 here because in every row we can see 4 elements or 4 columns. What if we increase this size? 5 and 5. Execute it and check the matrix. And we can see now the shape is 2 by 5 because we have 2 rows and 5 columns in each row. Also, we can say it 5 elements in each row. What if we add another row? Can you guess what will be our shape? It must be 3 by 5. You see, it's 3 by 5. And if you want to check the size of the matrix or vector or whatever, in future when we will create a tensor, if we want to check the size of a tensor, what will we do? We will simply multiply these values, the values of shape. So if we multiply 3 multiplied by 5, it will be 15. So the size of the matrix is 15. Or we can say there are 15 elements in the matrix. If we count, we will see there are only 15 elements. Well, if we want, we can check the size of a matrix or a tensor or whatever it is. And we can check the size using the size method of TensorFlow. So tf.size, and here we can pass our element. Here we can pass our matrix or tensor, whatever we need to check the size. Let's check the size of matrix first. And we can see its size is 15, what we have already checked. What about our scalar? tf dot size, and we can see its size is 1 because there is only one element or one value. What about our vector? tf dot size and vector, and we can see there are 5 elements in our vector. The size of the scalar is 1 and the size of the matrix is 15. Alright, we are finally here. Can't wait more. Let's create our first tensor. First real tensor in terms of mathematics. As we know, any array or list which is more than 2 dimensions is a tensor. So let's create a 3-dimension array. Let's name it underscore tensor equal to 3-dimension array, and inside here let's add some values 2, 4, 6 and 8. Let's call the constant method tf.constant. Pass our tensor, assign in a variable. Let's name the variable tensor, execute it and check it, and we can see our tensor object. But there is one difference, the shape. We will discuss about it shortly, but before that let's discuss about the dimensions. If we need single dimension array, then we will use single opening and closing square brackets like this, and value will go here inside these square brackets. And if we need 2-dimensional array, then we will use 2 opening and closing square brackets like this, and value will go inside this second square brackets. So 3, 5, 7 and 9. If we need another set of value here, then outside of second square brackets we will create another square bracket and pass the value here like 4, 6, 8 and 10. So when we are creating a 2-dimensional array, then we are not assigning any value inside first square brackets. We are always assigning value inside second square bracket. In the same way, use 3 opening and closing square brackets for 3-dimensional arrays like this 1, 2 and 3, and value will go inside the second square brackets. Inside the third square brackets. So here 3, 6, 9. Okay, there was one alignment issue. Okay, and if we want another set of value, then simply we will come here inside the third square bracket and we will add another row. So 2, 6, 9. Okay, and if we need, this is actually a row, so if we need another set of data, like here this is another set of data, not only row but another set of data, but this one is only row, not another set of data. If we want another set of data, then we will come here just after the first square bracket, and we will notice we will not add any value after first square bracket. We will add value after second square bracket. Actually, we will add row after second square bracket. So when we are doing this one, this is the data set of this array. So here we can give another comma, we can use another comma, and we can add another set of value here. This is the square bracket for set of value, and inside this square bracket we will actually pass value using another array or another list. Here 4, 5, 6, 7. And same goes here. 3, 6, 9. Okay, the rows and columns are not matching. That doesn't matter for now. So keep in mind about this one. The dimensions are the square brackets what are using for closing and opening. You see, there are 3 square brackets. Okay, so square brackets just before the value. Count the number of square brackets just before the value, or count the square brackets just after the value, just after the last value. So this is the number of dimensions. Here there are 3 square brackets just before the first value. So this one is 3-dimension array or list. And here at the same way we can check actually any one, either the first one or the closing one. After the last value there are 3 square brackets, so it's a 3-dimension array. I hope you understand this. So let's make a note here. Okay, we are getting notebook. Okay, the note, and we can say note, and here we can start writing note. If we need single dimension array, then okay, I'm writing it and I'm pausing the video so that it does not kill your time. Okay, so let's check out tensor again and understand this shape. Okay, we can see this is our value and shape is 1, 1 and 4. We know 4 is the number of columns or number of elements in a row, and this one is number of rows. And what is this? This one is number of set, the number of set of data. So if we create a larger tensor, then it will be more clear to us. So let's create another tensor, tf.constant, and here, as we know, this is the set of data, the comma. So we are creating 3 set of data, and we know this is where value goes. So this will be number of columns, or we can say number of elements, including the number of rows. This one indicates the number of row, and here inside this one, this square bracket, there will be number of columns or number of elements. Let's say we want 3 elements or 3 rows, 3 columns. So 3, 6, 9. So 3 elements means 3 rows. Sorry, 3 elements means actually 3 columns. And now it has actually 1 row. So we can create another row. 2 rows. Okay. And in the same way here, we will pass the same value for now. 1. Another one. Let's make it aligned for better understanding. And another row. So 1 set of data, 2 set of data, and 3 set of data. So this first value should be 3 and 1 set of row, 2 set of row, 2 set of row in every set of data. So this value must be 2 and 3 elements or 3 columns in every row. So this must be 3. Let's assign it in a variable tensor, execute it and check the tensor. Perfect. 3, 2 and 3. So this 3 indicates the number of columns or number of elements in each row. This 2 indicates number of rows in every data set. So 1 row, 2 row in first data set. In every data set there will be 2 rows. So this indicates number of rows in every data set, and this one is the number of data set. First data set, second data set and data set number 3. And how many elements in total, or we can say what is the size of this tensor? Simply we have to multiply all the values of shape. So 3 into 2 into 3, 6 and 3, it should be 18. So our total elements of this tensor is 18. Let's check the size, tf.size. Voila, it's 18. Okay, now let's do one more interesting thing. Let's copy this tensor and paste it here. What if we want 4 elements or 4 columns here? Only for this row we want 4 columns, and for all other row we want same column, or for every row we want different size of columns. What will happen? Let's execute it. And we are getting an error. Can't convert an non-rectangular Python sequence to tensor. It means column of every row should be same, or we can say all the row size should be same or equal. Either 4 or 5 or 3, it doesn't matter. Whatever the column or whatever the elements we want in rows, every row should have the same number of elements or columns. So we can say 12, even if we skip just one. All the row has 4 elements, but just only one row has 3 elements, it will not work. It will throw the same exception. Let's try it. We can see it's showing the same error or same exception. So let's make it 4 again and execute it, and it's working perfectly. Now, if you like the content, then just click on the subscribe button, hit the bell icon, give a thumbs up, and leave some great comments to inspire me for more great contents like this. See you in next lesson.